And welcome back to Chapter 6, where within this chapter we are going to focus on databases and information management. And so these are just some of the learning objectives that we will work through specifically within Chapter 6. When you think about a database, would you say that databases are always digital? Can you think of a non digital database? What about a telephone book? What are the entities, the attributes? Think about a library card catalog. That is, if you can find any of those around today still, or perhaps a mail order catalog. When we think about relational databases, we are working with what is known as two-dimensional tables, columns and rows. We have a key field, oftentimes referred to as the primary key, which uniquely identifies each record within each table. The relational database table for a supplier is divided into 6 columns for supplier number, supplier name, supplier street, supplier city, supplier state, and supplier zip. The column heads are together labeled as columns or attributes or fields. The rows are together labeled as rows, recorded. The first column is together labeled as key field or that primary key. The data presented in the table appears as follows. And so here, within each of those attributes or fields, you can see the specific information for each of those supplier companies. Data for the entity part have their own separate table. Part number is the primary key, and supplier number is what we would refer to as the foreign key, enabling users to find related information from the supplier table about the supplier for each part. This slide shows the second part of the graphic on the previous slide. Notice that the foreign key in this table is the primary key in the suppliers table. Think about what that purpose is of the foreign key. Can multiple records have the same foreign key? Here we're going to focus on what is known as an entity relationship diagram. And so when you're working with a relational database, there are what we term relationships within the various entities. And so we will take a look at that. The diagram shows 2 boxes separated by a line, with the box on the left labeled supplier and the box on the right labeled part. The line connecting the boxes represents relationships. The part of the line ending in 2 short marks near supplier designates a one-to-one relationship, while the part of the line ending with a crow's foot preceded by a short mark indicates a one-to-many relationship. it shows one part has only one supplier, while that supplier can provide many parts. This slide describes activities involved in designing a database. To create an efficient database, you must know what the relationships are among the various data elements, the types of data that will be stored, and how the organization will need to manage the data. Note that the conceptual database design is concerned with how the data elements will be grouped. What data in what tables will make the most efficient organizations. The shaded areas show which data came from the order, supplier, and line item tables. The database does not maintain data on extended price or order total because they can be derived from other data in the tables. The final design of the database for suppliers, parts, and orders has 4 tables. The line item table is a join table that eliminates the many-to-many relationship between order and parts. This diagram shows the relationship between the supplier, part, line item, and order entities. This graphic shows an example of an entity relationship diagram. It shows that one order can contain many line items. And so a part can be ordered many times and appear many times as a line item in a single order. Each line item can contain only one part. Each part can have only one supplier, but many parts can be provided by the same supplier. And so in that example, if I am supplier ABC, I'm able to produce part X, part Y, part Z. One of the most popular open source databases, which was purchased by Sun Computer, but now owned by Oracle, is MySQL. This database management system is not as sophisticated as high-end enterprise database systems, but still quite sufficient for many businesses. Other examples are provided here for you. A single human resources database provides many views of data depending on the information requirements of the user. Illustrated here are 2 possible views, one of interest to a benefits specialist and one of interest to a member of the company's payroll department. This graphic illustrates what is meant by providing different logical views of data. The orange rectangles represent 2 different views in an HR database, one for reviewing employee benefits, the other for accessing payroll records. Think of the green cylinder as the physical view, which shows how the data are actually organized and stored on the physical media. The physical data do not change, but a DBMS, database management system, can create many different logical views to suit different needs of users. And I apologize, that should just be cylinder, not green cylinder. And here we view several different types of operations within a relational database management system. The select, join, and project operations enable data from two tables to be combined and only selected attributes to be displayed. This graphic illustrates the result from combining the select, join, and project operations to create a subset of data. The select operation retrieves just those parts in the part table whose part number is 137 or 150. The join operation uses the foreign key of the supplier number provided by the part table to locate supplier data from the supplier table for just those records selected in the select operation. Finally, the project operation limits the columns to be shown to be simply the part number, part name, supplier number, and supplier name. One important function of databases is to bring about common definitions of entities and attributes, like what is a fiscal year, how to express date of hire, and defining business location. In pre-database environments, and even in some global companies, these definitions vary from one location or region to another. Microsoft Access has a rudimentary data dictionary capability that displays information about the size, format, and other characteristics of each field in a database. Displayed here is the information maintained in the supplier table. The small key icon to the left of supplier number indicates that is a key field. This graphic shows the data dictionary capability of Microsoft Access. For the field supplier name selected in the top pane, definitions can be configured in the General tab in the bottom pane. These general characteristics are field size, format, input mask, caption, default value, validation role, validation text, required, allow zero length, indexed, Unicode compression, IME mode, IME sentence mode, and smart tags. Illustrated here are the SQL statements for a query to select suppliers for parts 137 or 150. They produce a list with the same results as figure 6.9. Illustrated here is how the query in figure 6.11 would be constructed using Microsoft Access query building tools. It shows the tables, fields, and selection criteria used for the query. The graphic illustrates a query that performs the same operation as the SQL query in the last slide. The query pane at the bottom shows the fields that are requested. Fields, the relevant table, the fields that will be displayed in the results, show, and the criteria limiting the results to parts number 137 and 150, which is in criteria. Next, we're going to take a look at cloud databases and distributed databases. A contemporary business intelligence technology infrastructure features capabilities and tools to manage and analyze large quantities and different types of data from multiple sources. Easy to use query and reporting tools for casual business users and more sophisticated analytical tool sets for power users are included. Modern databases can store enormous amounts of information. Consider that PhotoBucket has 10 billion photos on tap, and YouTube plays 5 billion videos each day. Yet, making sense out of all of this data is a challenge for managers. What's needed are tools to organize the data, analyze, and describe what's happening in the real world based on the data. Data warehouses and data marts are two tools that bring data together and move it offline to storage areas where it can be analyzed without interfering with the transaction processing systems that produce the data. Data analysis, business intelligence applications would slow down transaction processing. And here we look at in memory computing and some of the benefits. A contemporary business intelligence technology infrastructures features capabilities and tools to manage and analyze those large quantities and different types of data from multiple sources. The diagram shows 6 elements: operational data, historical data, information of technology data, web and social media data, audio video data, and external data, together connected to Hadoop Data Lake. The element operational data is further connected to a data warehouse for extract, transform, load. The Hadoop Data Lake is also connected to the data warehouse and analytic platform. Data warehouse is connected to Data Mart and casual users, and all three are interconnected to each other. Casual users include queries, reports, and dashboards. Data warehouse is further interconnected to the analytic platform and power users. Power users include queries, reports, OLAP, and data mining. Power users and Hadoop Data Lake are further interconnected to each other. When we look at online analytical processing, or OLAP, this concept supports multidimensional data analysis, enabling users to view the same data in different ways using multiple dimensions. Excuse me. The multidimensional data model represents products, regions, actual sales, and projected sales. The upper rectangle rectangular face is divided horizontally into two parts, labeled actual and projected. The front rectangular face is divided horizontally into five parts, representing the products, nuts, bolts, washers, and screws, and divided vertically into three parts, representing the regions, east, west, and central. With terrorism so much in the news, you might ask how it is possible federal officials use data mining to identify potential or actual terrorists. For instance, if the national organizations were looking for terrorists, what kinds of associations, sequences, classifications, or clusters might you look for? The diagram shows 6 devices: client with web browser, internet, web server, application server, database server, and database, arranged vertically next to each other and connected to each other by double-headed arrows. Users access an organization's internal database through the web using their desktop PCs or mobile devices and web browser software. This graphic illustrates the way data is passed from a database through to a user with a web browser. Databases are much more than hardware and software. Indeed, the most difficult parts involve organizational and people considerations. Sometimes the careers of people and the fate of entire departments are involved with the data they collect. When you install a DBMS, you potentially are changing who collects what information about whom, where, when, and how. Databases are often collections of dirty data, data that is ambiguous, inaccurate, or incomplete. Before a modern DBMS system is installed, one large budget item is usually cleaning up the old data in old systems. The size of data quality problems varies from one database to another, but credit record databases usually exhibit a 25% rate of quality problems, with 10% of the records actually being wrong. Thinking about all of this, we will pick up with additional information in Chapter 7.